All right, welcome to another episode of the Golden Path to Spring One. My name is Dan Vega. I'll be your host for today's episode. With me, we are lucky to have Adib, who will be talking to us about securing the service-to-service call chain patterns and protocols. Adib, my friend, how are you doing today?
I'm doing very well. How about you?
Good, and I have a fancy shirt on today. We are celebrating May the 4th be with you. We are recording on May the 4th, so if you're watching this in the future, I have come prepared for today. So just a little housekeeping. We will be taking questions throughout the presentation. Go ahead and please ask your questions in the comments. I will be monitoring the chat. If I see something that we're kind of relevant, we're talking about, we'll go ahead and interrupt Adib and ask those questions. We'll also have some Q&A time at the end. So if you have questions, go ahead and add them to the chat. So Adib, what are we talking about today?
We are talking about a very common problem we have where you have one service that calls another service, which calls another service, and you're trying to figure out how to secure it. And it's kind of a bit confusing because there's like lots of ways you could solve the problem.
Yep. And we were talking a little bit before jumping on. Security is one of those things that is like really important to get right. And because it's really important to get right, can be very confusing and hard to understand at times, right?
Absolutely. This particular deck has taken me about 2.5 years to make.
Wow. All right. Well, then we get 2.5 years boiled down into what? What are we on here today? 90 minutes?
Something on the order of that, yeah. Hopefully we'll get lots of questions. So,
all right. Well, if you need me, I will jump off the screen. I'm going to leave you be and let you do your thing. Again, for everyone joining us in the chat or joining us all around, please go ahead and ask your questions, and I will monitor the chat. The floor is yours, Adib. Thank you for hosting today.
Yeah, you're welcome. Looking forward to it. All right. So let me just check. Okay, I'm seeing the same thing. All right, perfect. So securing the call chain. So I want to talk a little bit about what's our goal today. Our goal today is to kind of help you make a trade-off analysis of the various options that are available to you as a developer for securing the call chain. And the way we're going to do that is we're going to think about the problem and distill the securing the call chain problem to its essence. Then we're going to explore different patterns and protocols for solving this problem. Then we're going to map those patterns and protocols into possible implementation technologies. So we'll talk about a variety of approaches. And the idea is that as we go through it, we perform trade-off analysis of if I picked option A versus I picked option B. And my goal is that at the end of this presentation, you're able to apply this trade-off analysis to the specifics of your environment and make the best choice for you. So that's the plan. Please ask questions as we go along. If you want to know a bit about me, my name is Adib Saikali. I've been a software developer since 1995. And I like to joke that I've been a code janitor since 2014. I'm actually part of the Tanzu R&D team right now, and I work on Tanzu Application Platform, which is our developer experience platform based on Kubernetes, and on Azure Spring Apps, which is a partnership we have with Microsoft that allows you to easily deploy your Spring applications on Azure. I've done a lot of work with Cloud Foundry over the years with Spring and with application security. So I'm currently writing this book called Securing Cloud Applications, and if you'd like to get a free copy of it, you can click on the link. I'll throw the link into the chat here so folks can get it. You can download that for free. Let me see, how do I actually put an item in the chat? Comments, private chat. Oh, chat with everyone in the studio, okay.
And if you can't get it, you can, send it to me. There you go. And I'll go ahead and add it to the chat. Thanks, Adib.
Okay. Thank you. Yeah. So, so you can download the book and get a copy of it. Okay, so let's now talk about the main topic, which is the service-to-service call chain. So the best way to understand this is to actually look at a hypothetical scenario. Let's say you're looking to deliver a book. Like you want to buy a book, you have a standard product page from Amazon. Where are some of the services that can exist on this page? For example, you might have a service for the search box at the top, which tells you, when you start typing, it does the autocomplete and all of that. There might be another service over here that might calculate the price that you see, like what level of discount should we give this particular customer at this point. There's maybe another service for ratings. There's another service down here, perhaps, that tells you that if you ordered it soon, in the next 23 minutes, you're going to get it delivered by a certain date. You have the look inside the book service. You click on it, you can flip through the pages of the book, but not all of them. There's maybe a service that retrieves static information about the book, like who wrote it, when it was published, that kind of stuff. So if we look at a page like this and we kind of populate some hypothesize, like we would just make up some example services that might exist, you might have a customer making an HTTP request for a product page service, which calls a book details service. And it might also need to call the pricing service, which calls the buying habits service to decide how much discount to give you. You might call a marketing promotion service to figure out if there's any promotions going on and in pricing out the book. You might have a delivery estimation service that checks if you actually have the item in inventory, and might call out to different shipping providers to figure out the cost of and date required to get the book to you, and on and on and on. So that's what the call chain looks like. And in order to secure the call chain, we need to solve the problem of identity, because anytime you're doing security, whether you're authenticating a user or making an authorization decision, you need to know who's actually asking me to do something to what. So identity is the foundation of all authorization policies, and we need to distinguish between two types of identity. One type of identity is service identity, and the other one is user identity. So as an example here, if you look at this diagram, if you're the inventory service, you don't really care that Adib is on the other side. All you really care about is that, well, who's allowed to check on inventory? Well, the delivery estimation service is allowed to call me and request the status of inventory. Maybe there's other services that call it. But for this particular use case, the inventory service does not care who the customer is on the other side. The flip side of this is something that requires user identity. Let's take a hypothetical example different from the book one. Let's say you're building a money transfer service, and you're going to transfer money between two bank accounts, but one bank account is in Canadian dollars and one bank account is in US dollars. So you need to get the exchange rate. Now, the exchange rate service might not care the identity of the customer on the other side. It just needs to know that, hey, the money transfer service is allowed to call me to read the current exchange rate. On the other hand, the exchange rate service might very much care to know who's the user that's actually trying to transfer money between two accounts. So if you look at generalization of the problem of user identity versus service identity, you have a bunch of external clients, however language or technology they're written in. Requests come into your system, and they just, like, one service starts calling another one. So in this example here, you have this H service that's going to call a mainframe at some point. And it basically says, hey, how can H determine the identity of the service calling it? So in this case, it just needs to know that B is calling it or E is calling it. For whatever reason, that's all it needs to know. Whereas this guy over here, J might actually want to know who's the user that was on the web page that sent the request, or who's the user on the native mobile client that sent a request that ended up in the J service. So that's kind of essentially the idea of user versus service identity. They're two very different problems. There are some common elements in how you solve for their security, but in user identity is much harder to solve for than service identity. Because in service identity, there's no propagation. It's just H says B is calling me or E is calling me. It doesn't have to know why B is calling it. It doesn't care that B is calling it because, the HTML5 app called this guy here who called B, or the native mobile client called this guy who called this guy. Like, it doesn't care. It just says, okay, I'm H, B is calling me, B is allowed to call me, everything is good. Now, the challenge with the user identity is that we want to propagate user identity across services which are developed in different programming languages over multiple communication protocols. So I've kind of set up this kind of hypothetical scenario here to illustrate my point. So you have a user, the user makes an HTTP request to something written in Java. All right, now this thing says, okay, I don't know who you are, so I'm going to redirect you to my single sign-on service, and I'm going to ask you to log in. So the SSO service logs the user in. Now this service here, the Java service, knows who the user is. But then it makes an HTTP REST call to a service written in C#, which turns around and makes a gRPC call to an internal service written in Golang. And then that might say, put a message on a RabbitMQ queue or topic, and that might get picked up by a Node.js service written in JavaScript. How does this Node.js service here down on the bottom know the identity of this user over here? Hope you can see the challenge that we're trying to solve with propagating user identity through these layers of services as we go along. Okay? It's always difficult for me being on a stream because I can't see people's faces to see if anything I'm talking about is making sense. So I'm counting on you, the stream attendees, to maybe leave comments in the chat if this is making sense, or just ask a question if you need clarification on anything I'm talking about.
And I can be the community today. I'm nodding my head going, yes, this is types of scenarios that can get very confusing, even if they're all written in the same language, still very confusing. So I'll keep nodding my head in the background for you.
All right, thank you. So, oops, let me just put this out of the way here. All right. So kind of going along with this, if we look at what are the things that we need to solve the call chain problem, we need to solve, I think, in my opinion, 6 sub-problems. One is how to enable polyglot services written in different languages to work together. How do we secure the communication channels between the services? How do we determine the identity of the user? How do we determine the identity of a service? How do we propagate user identity across service boundaries over different communication protocols? And lastly, how to restrict which services are allowed to call each other. Okay, so the 6 problems we have to solve. And so let's break them and look at them in each one. Now, how do we enable polyglot things? The answer for polyglot is very simple. We stick to industry standards. So if you are using industry protocols and standards, those tend to have implementations in multiple programming languages. So I could have if I'm using OpenID Connect to log in, I don't care what programming language the OpenID Connect server is written in. It could be written in Golang, could be written in Node, Java, it doesn't matter to me. When we'll talk a little bit about a single sign-on with 2-factor like WebAuthn and FIDO2. We'll look at transport layer security, X509 certificates, JSON web tokens. These are all kind of well-established industry standards that you can find libraries for in all the different programming languages. So I think that that's how the approach we'll take for solving that problem. Now, in terms of securing the communication channels, well, you have to use TLS. It is the way. And you might say, but I'm just a developer and TLS is really confusing and I don't like, JKS files and these cipher suites and these mysterious error messages where I keep having to go on Stack Overflow, copy and paste stuff, and then it works, but I have really no idea why it worked and if it's secure. Well, I have bad news for you. You have master TLS, you must. It's just a fact that in 2023, we all need to be more security conscious. And if you learn a bit about the TLS protocol as a developer, your life will be a lot better. And I'll give you this analogy. If you ask me the question, how much should I know about TLS? I'll ask you, hey, how much do you know about servlets? How much do you know about the architecture of your application server? So as a Java developer, as a Spring developer, you probably know what an HTTP request is, what a servlet is, what TCP is, what a port number is. And when a request arrives, it gets assigned to a thread in the app server, which handles it. In short, you have a mental model of how a request is processed when you write your code in Spring. Similarly, what I'm suggesting is that you build a mental model of how TLS works so that you can effectively use the programming language and the framework libraries to get what you want done. So here's a list of concepts you should try to be familiar with. Number one, what is an X509 digital certificate? Two is, what's a certificate authority? What do they do? What's public versus private CAs? How does the life cycle of a X509 certificate go through? Like, how do you create it, destroy it, revoke it? How do you determine if you should trust a certificate? What is mutual TLS? What's this concept of something called a cipher suite, and how does it figure out which one to use? So you don't need to become like a super guru in this stuff, but you need a mental model of what these things are. So let's say you're working in your organization, and there might be a standard that a particular cipher suite is not acceptable. You shouldn't use it. And then you're writing some code, and then you try to connect to an external system, and you get an exception, and it's because it can't agree on the cipher suite. Well, that's happened to me in the past. So those are useful concepts to know. All right. So now that we've settled that you do have to learn a little bit about TLS, the book I'm writing actually covers this in kind of gives you all the background you need. So make sure to download a copy. So the user identity patterns and protocols. Let's now talk about how do we figure out user identity, because that's like the hard part about what we're talking about today. So when it comes to user identity, it turns out that our users kind of want to do things differently. So we might have a user who wants to log in with their, the thumbprint scanner on their Mac. Somebody else wants to use their face recognition on their phone to log into the shopping website. Somebody might want to use Facebook or some other social media account to log in, and other users might prefer to just use classic username and password. How do we accommodate all of those as a developer? What do you actually need to know? In 2023, there's really only two things you should know about. Number one is OpenID Connect. And that's because it allows you to write your application and do the single sign-on with anything that implements OpenID Connect as a protocol. And that's everyone in 2023. You can get like Spring Authorization Server, for example, to help you out with this. If you want to implement your own SSO service, you can do like a login with Twitter, login with Gmail, login with Stack Overflow, with whatever offers it. Now, one of the, I'm not going to say much more about it because OpenID Connect by itself could be like a whole 90 minutes. And we're talking about a larger problem here. So just add to your list, master OpenID Connect. And I do cover that in the book, but I haven't written those chapters yet. They're coming soon. So let's say you do this, and I want to have a thought experiment I want you to think about. So let's say you build your application and you followed all secure coding practices. You hired a security consulting firm to audit your code looking for security vulnerabilities. You trained your users to pick strong passwords and follow password management best practices. Nobody is writing their password on a sticky note and putting it on their keyboard, under their keyboard. And then your application also requires users to do a second factor, say an SMS token or an SMS value, like you've done this, or an authenticator app. So this is very secure. So the question is, how can you break into this application? So a question to the folks on the stream, if anybody's got any idea of how to break into this application, just leave me a comment in there. All right, no comments so far. So I'll help you out, okay? The answer is, if all of the software security is done correctly, you attack the human, because the human is the weak link, right? So what you do is you do a phishing attack. You build a website with a login screen that looks just like the real app that you want to break into. You trick the human into going to the fake site, and then you trick the human into entering their password. Now, if you've succeeded into tricking the human to go to the site, to the fake website with the intention of logging in, they're going to type in their password, and then they're going to type in the one-time password code too. Because if they already typed in their password, they're already been deceived, right? And so the fake site would just take the password, and then it would take the one-time token and it would log in the user. It would pass it on to the real site and then go and do all of the bad things that the hacker is trying to do. So we can kind of always count on attacking the human. If you watch, movies, there's always these movies where, like Ocean's 11 or Ocean's 7 or whatever, where some hero, somebody is trying to break into the unbreakable, super protected building with armed guards, alligators, and laser alarms and all of that. And usually they do it by dressing like the delivery man, or like they show up and they pretend to work there, and then they kind of talk their way in. So that's what attacking the human looks like. So the point is, all humans can be phished. Even if you're very security conscious, there's going to be a time when you're tired and somebody can trick you into revealing your credentials when you shouldn't. So we need a phishing-resistant authentication technology. And this is where what makes something phishing-resistant is that the technology you're using to log in is able to validate that you're talking to the real website, the real application, the real backend, and not to a fake one. And there are some solutions on the market for this today. So there's this thing called these YubiKeys. That's like 3 of these items here, like on my desk. And then there's this one here. This is from Google. So with these ones, you plug them in, you press the button, you can log into a site. These are widely supported. All the cloud providers support those. GitHub supports these. I use these with GitHub all the time. And so, yeah, that's kind of cool stuff. So let's talk a little bit about how this works so you get an idea. Sorry, so just one. So these little keys here, these are cross-platform. Obviously, you can carry them and use them with your phone. You can use them with your laptop, Mac, Windows, Linux, doesn't matter what it is. But these things are also built into your machine. So this is my MacBook, and you can see here I can do the thumb scan there. Your phone already has this. Like pretty much everybody today that has a modern phone that's, say, 2 years old already has all of this available without having to buy anything new. So let's actually get a demo of this, because a lot of the time I find people have not really seen this. So we're going to go to this website called Web Authentication, and we're going to do an experiment. So I'm going to ask folks on the stream to actually do this with me. So all right, let's go here. Actually, try it again. Okay, I guess this is from yesterday. I gave this talk somewhere else. Okay, so I'm going to type in my name here, Adib, and I'm going to say register. And normally when you register, you're used to people asking you to enter in a password. In this case, I got this little pop-up that says, I'd like to use this device. So I have to go here and, oops, I locked my screen. Didn't intend to do that. Continue. Okay. Now it's actually saying, okay, success. You can see how I signed up. So at this point, I can click on Authenticate, and it pops up again and says, hey, you should tell me who you are. It now knows that I should log in with this. So when I click Continue, you'll notice it's doing the standard macOS pop-up requesting that I scan my fingerprint. All right, let's do that. Okay, now I'm logged in. And you can see here that...
Hey, Adib,
yeah?
We can't see your screen yet. I think when you did that, it went away. So.
Oh, okay. Hold on. I will share my screen again. Window. Entire screen. Okay. Screen 1. Share. Okay. Can you see my screen now?
All right. Let's throw that back on there. Cool.
Okay. All right. I will go back to repeat this step here. Okay. So sorry about that. So I'm going to click here on the register. And it says, hey, how would you like to identify yourself to the site? I'm going to say I want to use this device. Click Continue. You can see I get the little pop-up that says, go scan your fingerprint. So I will scan my fingerprint. Oh, I already registered. Okay, so we'll cancel this, and then I'll show you the authenticate piece. Right. When I click on authenticate, it's going to say use a, do you want to scan your fingerprint? Yes, I click on this, and I can scan my fingerprint. Okay, now I'm logged in, and you can see here that it knows who I am. So what I'd like somebody on the stream to do is to go to webauthn.io. Maybe you can do this for me, Dan. Go to webauthn.io, register, but when you register, use Adib as your username, or anybody else can do this. And I'm going to wait until I can see more credentials associated with that ID here so I can more clearly explain how it works. You can try it from your cell phone. You can try it from your laptop. It should work.
So I was able to do it, but it failed. It said registration failed. Client data challenge was not expected challenge.
Ah, okay. All right.
So when I did
Okay.
it, I had a little QR code come up, and so I had
Yeah.
to scan that.
Yeah, you had to do that with your phone. This is the new Mac,
Yep.
new feature of iOS. Yeah. Okay. So that's probably like unhappy because maybe I already knows that I registered it, but
It says I
it's
could
okay.
try another way too. I can try this device. Let me try this
Yeah,
device.
try this device. That should probably work.
Okay,
And then
I
you have to
tried
hit
this.
continue. Otherwise, it'll lock your screen when it pops up the little scanner.
I think I get the same problem. Registration failed. Client data challenge was not an expected challenge.
Okay. All right. Which browser are you using?
Chrome.
Oh, okay. All right. Well, we'll just keep going. That's fine. I'll just explain how it works.
Sorry about that.
No worries. No worries. It worked yesterday. I was doing a talk, and somebody in the group in the crowd managed to do it.
All right.
So essentially, what happens is that when you're doing this, it will in the authenticator will create a public-private key pair that identifies the user. The public key is shared with the website where you're trying to log in, like for example, webauthn.io, and the private key is never leaves the device. So if you use the thumbprint scanner on the Mac, it's actually stuck in whatever the T2 security chip that's in there. If you're using your phone, it's stuck in the security hardware on the phone. If you use one of those YubiKeys, like say this one here, I don't know if it'll show up on. Here's one of the blue ones. It'll be the private key will never actually physically leave the device, whereas the public key is shared with the website. And the authenticator is when it tries to log in, it actually gets from the web browser the URL where you're trying to log in, and it matches that with what's stored in the authenticator. And this is why you can't fool it. So it doesn't look at how the website looks like. It actually looks at the URL of the site. And if there's no associated private public key pair with that, it can't log in. Okay. So point here is you can fool the human into thinking they're on the real site, but you can't fool the browser and the authenticator at the same time. Just to show you that this is kind of used widely, if you go to like GitHub, actually I'll go to GitHub just to show you how this works with GitHub. If you don't have this turned on in your GitHub, you should. Let's say I go to settings and I go to developer settings, and I don't know, let's go here and let's do something. Oh, well, it's letting me do this. Hold on. It should actually challenge me. Okay, let's go to settings and developer settings, personal access token. Let's make a new. See, now it basically says, would you like to log in? And the answer is yes, or you need to verify yourself. So I can use my security key. And it's saying, okay, great. I have different security keys registered. I'm going to click yes. You can see it gave me the pop-up, and I validated myself to. Well, why did this continue? Okay, I think I was just being very impatient. There we go. So that's how you see it in the real world as an example with GitHub. Okay. So the magic that makes this work is if you are using it in your web application, there's some JavaScript API called Web Authentication API, which is supported by practically all modern web browsers. And you can see here that we're at 94.85% of browsers support it. Okay, so it's a safe bet to use it. It's as good as it gets for JavaScript. And what's kind of happening under the covers, so you have a better understanding of how this works, is that regardless of what physical authenticator you're using, when your application uses the WebAuthn API in the browser, it's kind of calling the web browser itself, which is using a lower level protocol to communicate over Bluetooth and Wi-Fi and USB to the actual physical device that has the authentication logic in it for generating the username, the private public key pair. And then in your client-side JavaScript, you exchange stuff with the server. So if you want to know how to do this in Spring Boot, I actually forgot to include this in my deck. So I'm going to actually just go to the repo here. So here is a link. I'm going to put it in the private chat. Maybe then you can share it with the group, please. So this is going to, there's an example here that shows you how to implement this with Spring, essentially, with Spring Boot. Right? So that covers the topic of how do we establish the identity of the user. Now we're going to switch to a different topic, which is how do we establish and represent the identity of a service. Are there any questions at this point from anyone on the stream? All right. So let's do service identity. So for service identity, we can break this problem into 4 different questions that we have to answer about it. Okay. So we need to know who the service is that's calling us. How do we represent the identity of the service? Is there some sort of data structure document that we can use to describe a service's identity? And then if we have an identity document for a service, then the question is, who issues the service identity documents? How does the service obtain its identity documents? And should identity documents kind of contain access control permissions in them? So let's go through these 4 questions and think our way through this. So what are the document formats should be used to describe a service's identity? Well, there's really 2 industry standards. Remember, we're sticking only to industry standards so we can be polyglot. There's X509 digital certificates, and there's JSON web token. Those are the 2 kind of common ones out there. So let's put them side by side and see the similarities. So X509 and versus JOT, X509 is a structured binary data. JSON versus a JSON object, literally JSON text. When you send them around, you'll end up base64 encoding both of them. Both of them are industry standards defined by IETF. So there's 2 RFCs. One became a standard in 1999, the other one in 2015. They're supported in all programming languages. There are protocols that build on top of them. So for example, TLS is building on top of X509. OpenID Connect builds on top of JSON Web Token, JOTS. And they both have well-defined validation algorithms that kind of tell you, how do you know that you can trust an X509 certificate? How do you know that you can trust a JSON Web Token? In both cases, you have to be very careful to make sure you follow the validation algorithm correctly in order to, decide to validate or not. People make mistakes in the implementations of these things sometimes. So what are the differences between them? The differences is that the X509 certificates have a rigid schema that's defined in the standard, whereas JSON Web Tokens are kind of like, you do what you want. It's a JSON object, put whatever fields you want in there. So it's a very flexible structure where you can put stuff in there as a user. The X509 certificates, you have to have a public key and you have metadata about the key, like the key, how it's signed, and various other things, who owns it, blah, blah, blah. Whereas with JOTs, you can put whatever you want. The X509s are usually issued by what's called a certificate authority. The JOT tokens are usually, you get them from an identity provider like Spring Authorization Server or Okta or Auth0 or Active Directory or something like that. You could just make a JOT token yourself in the app. It's pretty easy. The X509 certificates, we don't hide the contents of the certificate. You can read everything in the certificate. Whereas with the JOT, you can actually, if you choose to, you can encrypt the content and preserve the privacy of it. Another huge difference between them is that because the X509 certificate has a public key, you can use it to bootstrap a secure communication session, whereas you can't do that with JOTs because you don't know if they have a public key. Then they could have a public key, maybe they don't. So the way you validate the X509 certificate is you use the signature, the public key of the issuer, of the certificate authority that issued it, to check that it hasn't been tampered with. And if you trust the public key of the certificate, you trust it. With the JOT tokens, you can use the public key of the issuer, or you can use a shared secret to do that. So generally speaking, there's kind of this impression that public key infrastructure can be complex to set up, which is true. It's not an unrealistic impression. JOTs are simpler to work with. And so I hope this gives you a sense of these two identity documents. So what I'm trying to get at is, if I'm a service and somebody's going to call me, I'm going to expect the person that's calling me to present me either with an X509 certificate that identifies them, or they're going to provide me with a JSON web token that identifies them. So let's look through, how does that actually work? So when you use an X509 certificate, typically what you'll end up doing is something called mutual TLS. So the client is going to connect to the server. The server is going to say, okay, hello client, here's my certificate that identifies me as a server. And then the server will say, can you please tell me who you are? And so the client will send its certificate to the server. And if the client and the server are happy and decide that they trust each other's certificates, a secure connection is bootstrapped and you have an encrypted communication link. So that's typically how that's done in the context of X509. In the context of JOT tokens and in HTTP requests, you typically just have an authorization header, and then you just go authorization bearer, and then you have the base 64 encoded version of the JSON web token, which you can validate on the receiving side. All right, so any questions so far? Okay. So now, what are the strategies that you can have for obtaining service identity documents? I argue that there are two ways you can do it. You can, as a service, you can go and and request that somebody give you those documents, or the platform that you're running in can inject you with your identity documents. So let's see examples of those two scenarios. So when the application requests it, could be something like this. The app could go to an OpenID Connect provider and say, hello, I'm this app. Here's my client ID. Here's my client secret. Can you give me a JOT token so others can trust me? Or maybe you go into Azure Key Vault and you retrieve the certificate that you're supposed to use to make your request. Or maybe there's some proprietary API that you use with a certificate authority to get yourself an X509 certificate. So the challenge with this approach is that frequently you actually need a secret to get to the place where you're going to retrieve your identity from. So you need a client ID and client secret in the first example here. Maybe you need credentials to access Azure Key Vault. So it introduces a bit of chicken and egg. You need a secret to get the thing that you need to identify yourself to others. So it's not really ideal. So let's talk a bit more about platform-injected identity. So platform-injected identity relies on the idea that your application is running in some sort of platform, and the platform you're running in knows who you are, and so it can vouch for you. So these are some examples here of of common ways that people do this. So let's say your application is running on Cloud Foundry, also known as Tanzu Application Service. There are two environment variables available to your app. You could read the cf_instance cert and cf_instance key environment variables, and those will contain an absolute path that to a files that contain the public-private key pair that identifies that particular container instance. Oh, and that key pair is rotated every 24 hours. So that's kind of pretty neat. So that's leveraging a platform. If you're running on Kubernetes, you can actually look in under var run secrets kubernetes.io service account, and you have a JOT token there that actually identifies the pod that you're in. And that allows you, through the magic of federation and other things, to make it so that your application can identify itself to others using this JOT token, this service account. For example, if you're running on EKS on AWS, you can configure EKS to you can configure the AWS identity and access management to use to say, hey, if somebody calls and they present me with this JOT token that's from a service account, I should trust them, and this way your applications running in a pod on EKS don't need to have a password to access, say, an S3 bucket, as an example. In the case of Istio, it'll generate X509 certificates that identify the application, but those will not be given to your app. Those will just be given to the site, the Envoy proxy sidecar. In Kubernetes, there's a package called Cert Manager that you can use. Let's click on this one here. And what Cert Manager has a feature called the CSI driver here. So if we scroll down, we're just going to look at an example here of a pod. So you can see in this pod, we have told it that there's a path /TLS where we would like to make our certificate available. And well, how does the certificate get there? You can see here there's a volume, and the volume is of type CSI certmanager.io, and there's some attributes of this volume, such as which issuer to use, which certificate authority to use to issue the certificate. And then it says, okay, what are the DNS name that should be put in the certificate? And you can see here it's taking the pod name space .svc.cluster.local. So presumably using something like this guy here, you should be able to get a certificate that identifies your application. You could also just put this thing in a Kubernetes secret. Like you create a Kubernetes secret which has your X509 or JOT or something else. If you're on a virtual machine, say on Azure or AWS or GCP, there's usually like a metadata service you can call. So in the case of Azure, you can go to like 169.254, 169.254 metadata identity OAuth2 token. And that's only available inside your virtual machine. And you can kind of get your identity. So I hope this idea of platform injected identity is starting to make sense to you through these examples of different platforms and how they handle it. Dan, are you still nodding your head, or do you have any? Am I lost you?
No, you have not lost me. I'm following right along and nodding my head. So.
All right. Well, thank you. So if we put these two side by side, like application requested identity versus platform injected identity, the nice thing about platform injected identity is you don't need a secret in order to get the identity, right? Like you just look for it in a particular path and it's already been put there for you by the platform. The downside of it is your app must run in a supported platform. Like if your app is not inside of a Kubernetes cluster, you can't use the service identity that's assigned to you by Kubernetes. The really nice thing about platform injected identity is it is much easier to apply security best practices such as secret key rotation, auditing, when you have a platform injected and managed identity as opposed to application requested one. On the plus side, if you're doing the application requested one, well, you can run anyway. You don't need a platform, but there are downsides. Okay. So what are the recommendations for service identity? So I think that, Whether you use JSON Web Token or X509, those are kind of well known in the industry at this point. What's really important, in my opinion, is that you use a platform injected identity, because that makes life so much easier and more secure. And so where does the application obtain its identity documents? Well, it should just get them from wherever the platform it's on puts them. And this is where, Spring is very good at helping you deal with this type of stuff. Should the identity documents contain access control permissions? I don't have a dedicated slide to this, and it'll take me a long time to explain why. But the answer is no, it shouldn't. What you want the identity documents to contain are just who this person is, who the user is, who the service is. You don't really want it to have a list of what the user is allowed to do and not allowed to do, partly because the identity of something does not change over time, whereas what they're allowed to do and not allowed to do changes. And so if you start putting permissions into identity documents, you start having to check if the identity document is if the information in it, is it up to date? Has it just changed since before I got it? Cache invalidation is one of the hardest problems in computer science, so we don't want to try to even solve it here. So we'll stay away from it and say, let's keep identity documents just like that. Identity documents, they're not stating what you're allowed to do and not allowed to do. So just to reinforce, prefer platform injected identity over not platform injected identity. All right, so now let's talk about the next problem. How do we propagate user identity through the various systems? Well, just to remind you of that, we're propagating user identity across services developed in a variety of languages over multiple communication protocols. And I have bad news. As far as I know, there's no industry standard way to solve this problem. So what you're going to have to do is you're going to have to pick a way of solving this problem, a convention, a pattern, an approach within your system. But if you move to a different system, they might choose to do it differently. This isn't like HTTP or TCP, like where everybody's doing it exactly the same way. So what are some patterns that you can use? So let's look at some patterns here. So one pattern that you could use would be something like this. You have a user, you go through, you log in, it knows who you are. So you've got this UUID that identifies the user that this Java service knows. So it can put it in a custom HTTP header and, call the C# service and then say, okay, the user's ID is this much, is this UUID 95, ECD, whatever. And then if this C# service wants to know more about the user, it calls the user info service and says, hey, can you tell me about this user with this user ID? And then it turns around and calls the gRPC service, and it puts that UUID in the message body. So it goes here, and it has to go back to this user info service to get the information. And then it could then put the user ID for the AMQP message in a message header, which is read by JavaScript. So you're starting to see, I hope, that, okay, this works. I can know who the user is, but there isn't really like a standard place to magically propagate the user's identity down the line. I have to pick an approach for doing that as a developer, architect of a system. And there isn't really a right way of doing this. So, the disadvantage of this approach is with just passing in just the ID of the user is you have these extra calls to get more information from the user info service. You could also just decide to pass a JSON Web Token that as a header that has some information about the user, because the JSON Web Token, you can use that to make sure nobody is tampered with it. And that could include basic information about the user, maybe their name, their email, phone number, whatever it is that you need, the user ID, a bunch of basic stuff that identifies the user that you can send around your system. Okay. So should you pass a document or should you just pass the user ID? I think that it's up to you. You do what's best for you. Passing the user ID is pretty simple, but the services need to, you have this dependency on the user info service that incurs an extra network hop. Perhaps you can avoid that by packaging more of the user's information in a JOT, but then the information you're sending on each network hop is larger. And, maybe you implement a hybrid approach where you have some information in in the user, in the token, in the document, and some other stuff you have to get from a user info service. All right, so moving along. Well, what do you do? Let's say now we have this chain here. What can you do? Well, you could end up in this situation, which is like what's called like token relay, where A is going to go to something, get a red token, which it passes down to B, and B just takes that and passes down to C. And you really hope that no one messed up and sent the wrong token. You really hope that no one stole the token and is now sending it and using it to steal stuff. There was a recent big security incident, I can't remember it off the top of my head, where it involved people stealing, hackers were stealing these bearer tokens. So bearer tokens, for the most part, are not good. But what choice do we have? We have to kind of use them most of the time. The other approach is you can do like something that's more like this token exchange pattern, where you kind of go to your auth service and you say, hello, I'm the A service. Maybe you do that with your X509 certificate that's been assigned to you by the platform that you're running on. And you say, hey, I want to call service B, and this auth service says, okay, I'm going to give you a blue token, and you can only use this blue token to call B. And then you call B, and then B goes, hey, A called me with this token, and hello, I'm the B service, and I really would like to call C to do something. Can you please let me do that? And then the auth service will kind of give out like a red token that you can only use once, and then it will use that to call the C service. And like this is much more secure than the previous one, but it's also much more complicated to implement. So it's really up to you to pick what you want to do. Okay. Are there any questions in the chat at all, Dan?
No, I have some comments saying it's very informative. It's making sense. So people are nodding their heads right along. I guess I had one question in the sense of the JOT. I saw your explanation of having to obtain a JOT. So normally in an application, I have to call some service. Here's my username and password. Here's the JOT back. Now I can make a request to the service with the JOT, and I should be able to make that request. Are you saying that we still do that, but now once we have the token, now that we have the JOT, we just kind of pass it down to each app as we're going through?
That's kind of what's okay. So when you are, it's a really good question. I want to clarify it. So remember, we're talking about two separate things: user identity versus service identity. Okay.
Yep. Mm-hmm.
So in the world of if you're using, if it's a matter of service identity, which is not what I'm representing here, this is here more about user identity.
Okay.
You go to the OpenID Connect server, you say, here's my client ID, client secret, give me a JOT that identifies me as service A. Then you call B and you're saying, hello, B, I'm service A. And B can decide whether it wants to trust you or not because it knows who you are. You're service A, right? Mm-hmm. But it doesn't know who the user is. You get what I mean?
Yep.
Okay. Now, if you're doing token relay with user identity, A would just happen to be the first one. It says you're not logged in, so it sends you to the OpenID Connect server, which now says, okay, Adib is the user, and then A calls B, and then it might have its own service. It has its own service identity token that says it's A, so B can know that A is calling it, but it also has another one that says, oh, and the user is Adib.
Right. Yes. Yeah. So I guess my kind of confusion there was in a normal scenario, I'm a user asking to identify myself. But in a service, the service is saying, hey, I'm identifying myself as service A. How did that get down to C? Like C.
Oh, so C
B is calling C and not, with A's credentials, if you will, right?
No. So it's you're not propagating the service's identity. So
okay, that's what I was confused.
Yes, because there's no need to propagate service identity. C doesn't really care that it was A that called B that called C, right? C only cares that, okay, who's making the request to me? Okay, B is making the request to me. It's basically saying, I need you to prove two things for me to perform the request. Number one, I need you to prove your identity that you're legitimately allowed to call me. So,
Okay.
and you've done that because you've proven to me your service B, right?
Yep.
Via either a JOT token that represents service B or an X509 certificate. And then there is like, what are you actually asking me to do? Okay, now you're asking me to transfer money between these two accounts, but
Right.
I'm not going to do that just because you're service B. I
Right.
actually need to know that you're acting on behalf of the user
Gotcha.
who's actually allowed to do that.
Okay. Okay, cool.
Yeah, I think it depends the slide with two tokens to represent the two identities.
No, like you said, when you start getting into some of this, it can be pretty complicated. So I do have a couple questions here. Does a two-way SSL between services do the trick?
Mutual TLS between two services is very good at the service identity portion. And that's what we covered earlier with the choices that you have. Yeah, absolutely. Cool. It helps.
All right. And I have another question. Isn't it expensive to call an auth server for each request in the API call?
Yeah, like this one here, it is. Absolutely. And the question is, what is more expensive? Getting hacked?
Yeah.
Or being secure, right? Like
data breaches are very expensive.
Yeah, I mean, this is why like I'm staying away in this presentation from telling you what to do. Right. What I want people to understand are the pros and cons so they can understand what makes sense in their situation, right? Yep. Like, let's be honest about it. Like, my house is just a regular house in the suburbs. I don't have like a massive door with like 5 locks and like iris scanner and like, you know, all the stuff. But if you went to the bank and you tried to get into the bank vault, you know, you probably have all sorts of different types of locks. Right. So you have to match the level of security to the use case and the situation you're in, which is why I'm like, there isn't one right answer all the time.
Yep, for sure. That makes sense. Cool. Thank you.
Yep. Okay. So now that we've kind of got through a lot of these patterns, let's actually look at some popular tools that are out there and what they bring to the table for solving this, securing the call chain problem. So I think that you can solve this problem using a variety of tools. And yeah,
I'm sorry, Adib, I have one more question that came up.
Yeah.
Are there protocols that make user identity easier to handle than REST?
No, it's not. It doesn't have nothing to do with REST. The problem is how you define the problem. Well, I defined the problem as you're trying to propagate user identity across protocols like, say, gRPC, HTTP, GraphQL, whatever it is that you're using. Yep. And for things written in different languages, which is the most complicated version of it. So yep. I don't know of something that makes this problem go away in all cases.
Yeah. Okay. Thank you. Sorry.
Yeah. So when you try to solve this problem, you can choose to solve the problem at different levels. You can say, like, the only thing I have is the programming language framework I'm using. For example, Spring. All I have is Spring. Can I actually solve this problem with just plain old Spring and Spring Security? The answer is yes. You just get to write a lot of code, right? You could say, okay, well, I have a framework, but I'm going to add an API gateway to the picture. Maybe you add Spring Cloud Gateway. Now, can that make my life easier? Of course it can, right? But then you say, okay, not only do I have a framework and an API gateway, now I'm going to add a platform. Maybe you add Cloud Foundry, maybe you add Kubernetes. Well, you can go a step further and you can say, well, I'm going to also add a service mesh, right, into the picture. Or I'm going to add an identity provider, like, say, Spring Authorization Server. So let's go through these and look at the value and the benefits that each of these brings to the table, so you can kind of like have a good place to start. Okay. So what does Spring bring to the table? I've kind of broken it down into the different layers of the various Spring projects. So from the core Spring framework, where it really helps you out is you tend to have abstractions for, say, for example, Spring MVC, and you have, you know, REST template and web client and all these types of things. And as you're implementing security and you need to propagate that identity, say, from one system to another, because you're using Spring, you can actually create interceptors, you can create filters. There's well-defined extension points within the core Spring framework so that you can like do something in a common way regardless of what it is. So that's very helpful if you're using Spring for propagating user identity, for example. You can make it invisible to your regular application code that you're writing. It just happens when you call a REST template or a web client that it does the right thing because you added code across all of those instances to do that. Well, how does Spring Boot help? Well, Spring Boot is very helpful because you can externalize all sorts of configuration, and you got this thing called auto configuration that you can leverage to configure, say, all of the interceptors that are going to like, handle the filters that are going to handle stuff in your web client on the way out and on the way back. There's a very nice video that you should all watch if you haven't watched it. It's from last year's Spring I/O conference, and it's called Building a Framework on Top of Spring Boot. And what Ruben does in this video is he actually kind of goes through all the, like, say, okay, I'm building a lot of microservices in Spring Boot with a team of developers, and can I add my own kind of company-specific auto configuration to make my Spring Boot developers' lives easier, right? Like, these are the things that the Spring Boot team can't do because they don't want to tell you how to do certain things, but you can totally say, within my company, we prefer to use Spring Boot like this, right? So he goes through and does a really fantastic presentation on this topic. So watch it if you haven't. So then the next layer is Spring Security. So when you add Spring Security to the mix, you're going to get support for OpenID Connect. So you can easily create single sign-on in your Java Spring Boot app with Spring Security to say, hey, here's how you log in. It's very easy to implement OpenID Connect resources like @resource server. You can add that to as an annotation to your backend. Now you have a resource server that will only accept JWT tokens that are valid. There's extensive support within the Spring Security for correctly validating JWT tokens. There's also a project called Spring. There's the standard Spring Security authorization annotations, @pre-authorized and all of that method security stuff. Great integration for all of this with web client and REST templates. So life is easy with Spring Security. The next project that'll help you out is Spring Session. And what Spring Session will do is, once somebody is authenticated and logged in, you need to remember that they're logged in. You typically put that in the HTTP session, but the HTTP session is inside of one Java virtual machine. But what if you're scaled out your application to more than one instance? So Spring Session lets you externalize your HTTP session to an external store, like a Redis or a Postgres or a Gemfire or wherever you want to put it, right? Or Hazelcast, right? Somewhere else outside the process, so that it just works. Like, Spring Session has to be the easiest project in the world to use, because all you have to do is just add it to your class path, add some configuration in the YAML, and you're done. You don't actually necessarily interact with it directly. It can do other things for you. I wrote an article about this in, I think, 2015 or something like that. You can search for it, which explains some of the other use cases for Spring Session, like impersonating users and having more than one HTTP session and other things like that. Maybe even maintaining a session in a backend process that is, for example, just processing messages off a message queue. Now, the latest kid on the block is the Spring Authorization Server, which just GA'd in December of 2022. And the Spring Authorization Server is what you would use if you wanted to implement your own single sign-on server. It supports, you can see here, a list of all the different standards, security standards that it implements. However, it's a toolkit for building your own authorization server. It is not a fully baked authorization server you could just download, deploy to production. You actually have to write your own code, your own Spring Boot application that leverages the libraries that are part of the authorization server to implement an OpenID Connect server. The value that it brings is you don't have to implement the security code, because implementing those security standards is very tricky and very time consuming. So it helps you that way. If you want to learn more about how to use it, in the link that we put in the chat earlier, this one here, web auth and Spring. There's actually two subdirectories. There's a subdirectory called auth server basics, and that shows you all sorts of different ways of using the various features of the auth server. Okay, I'm in the process of upgrading it to Spring Boot 3 right now. It's currently using Spring Boot 2.7.11. And I need to upgrade it to the GA version. This is still using the pre-release version of the auth server. But look for that in a few days. Yeah. Then there's also the Spring Cloud Gateway project, which is quite helpful because it is a full-fledged API gateway, which you can kind of configure to do whatever you want it to do. I'd love to share with you that we do have a commercial version of this, which runs as an operator on Kubernetes. You can actually deploy Spring Cloud Gateway directly into Kubernetes, the commercial version, and then you can kubectl apply and request that it spin up instances of the gateway. It has all sorts of really cool commercial features that make your life easier. So that can be very helpful because you can use it to front various other services.
Hey, Adib. Yeah, so I have a question about this because we get asked about this concept a lot. If you have a bunch of services that are going to talk to each other, you probably don't want to re-implement authentication at each of the service levels, right? One of these patterns is putting all of these services behind something like a Spring Cloud Gateway, right? So authentication is done at the gateway level, and then you basically, if once you get to that level, you're authenticated. All the services are now kind of in a trusted zone. Is that a pattern that you see often? Is that a good solution for that type of situation?
No.
No.
I'm going to say well, I'm going to qualify the no. So what I don't like is when I hear the word trusted zone,
Right.
because there's a concept which is like, the problem with trusted zone is that you don't want to be in a trusted zone. You can't really. There's no such thing as a trusted zone in a modern data center, modern enterprise. So everybody needs to validate and check everything as close to the data as possible. So it is part of the toolbox in that you could use it to say, I'm not going to bother all the services behind it by passing the request to them if this user is not allowed, is not logged in. Does that make sense?
Yep.
So you're kind of failing early, and you're saying, like, think about it like this. You're trying to get into a hospital, right? Or like something like a campus, something with multiple buildings. So you or the airport, right? Okay, let's use an airport example. So you get to the airport, and then you get through a layer of security, and then when you try to get into the security line, they go like they want to see your boarding pass, right? If you don't have a boarding pass, they don't even let you go through security. So it's a little bit like that. But in the airport, once you get through security and then you're trying to board the plane, they still want to validate that you have a boarding pass.
The right ticket. Yeah.
They check your ID and the boarding pass. So it's a little bit like that is the approach we want to take.
It's the top level security infrastructure, and then as you get to the service, you still want to know, are you able to authenticate here?
Yeah.
Are you trusted?
Yeah, exactly. So it's great for you should definitely use it to front your services, but you should not have the services behind it wildly and trust everything just because,
Right.
You may not, you might want to make them go like, only if the call came provably from the API gateway with the right set of other controls.
Okay.
So
cool. Thank you.
Yeah, this is the last slide. How are we doing on time? Are we out of time yet, or?
No, we're good. We had about 20 minutes here, so.
Okay. All right. Perfect. So this is the last slide, and so this slide here is the standard kind of like, what if I have this thing called a service mesh? Well, let's talk a little bit. Some folks on the stream may not know what a service mesh is. So in the context of a service mesh, what's interesting about it is the following. We have a service A here, and we have a service B, and A wants to call B. And as you can see, there's no line connecting A over B here, because what we're saying is that that's not how A talks to B. Instead, A is going to talk to a proxy, it's usually called a sidecar, and A is going to talk to that proxy, which is going to talk to B's proxy, which is going to deliver the stuff. So The communication between service A and its proxy, this line up here, think of it as localhost. That's not using any kind of security or encryption. There's other controls in place that essentially ensure that this guy here, this proxy, only A can talk to it, and all that type of stuff. The advantage of this, what we're trying to do with this approach, you'll see that this particular proxy and that particular proxy, they're all getting their configuration settings from the global control plane, in this case, Istio. And you'll notice here that it has a certificate authority that's part of Istio, which is delivering certificates to all of these proxies. So when these proxies talk to each other, they automatically do mutual TLS. And this way, this particular service get the benefit of communicating with each other over mutual TLS, but without having to actually do mutual TLS themselves, or know how to set it up. And so what the service mesh is trying to do is to take on a whole bunch of these security concerns and have them happen in the infrastructure instead of happening in the app. Now, one of the interesting things about it is you'll notice here there's this thing called an ingress. It's called an ingress gateway, and there's an egress gateway. And it's the same story. So you have somebody coming in, they want to come in from the outside in, they hit the ingress gateway, and there's think of this like an API gateway, like a Spring Cloud gateway, for example. And that might be over mutual TLS. It might have a JOT token to identify the user, and then it validates it. And then if everything is good, it will send the request onto the proxy. There's also all sorts of YAML that you can add authorization policies to say whether service A is even allowed to call service B. So service mesh is quite a complex type of infrastructure that you deploy into your environment in order to achieve some security objectives. It can be helpful, but it's not going to solve the user identity propagation problem. That you still have to do on your own. Service mesh can definitely solve the service-to-service identity problem, and it can give you, it can do things that you otherwise would have to do in your code. So I don't want to get into today onto whether you should use service mesh or not. That's a debate and a topic for another day. What I do want to mention is that it is part of the toolbox that's available to you if you're on Kubernetes and you have a service mesh available in your Kubernetes environment. So I'll pause here and see if anybody's got any comments or questions or thoughts about anything we've talked about today.
Yeah, so if you have any questions, please go ahead and add them to the chat. We have some time to get through some questions, so go ahead and ask them. Man, I'm telling you, something about security just hurts my brain. It's just, and it's not this talk. It's that I've been dealing with it all week, and it's been kind of front of mind for me. So
Right.
There's just so much to think of. And again, it's such an important topic that you want to make sure you get it right.
Yeah, absolutely. I mean, this is why I'm been slaving away writing this this book on. Where's the link to the book again?
We did put it in the chat.
Yeah, no, I'll pop it open again. I'll just bring it over here. This is why I've been working on this book. It's because it's the stuff I wish I knew. I had to learn all this stuff as a developer the hard way.
Yeah.
Literally reading the cryptography books, going through the online courses and videos where a university prof is talking through all of the math, right, that you need to understand this. And I'm going like don't need to know that, but it's the only way to learn it, right?
Right.
So I'm kind of filtering it all and simplifying it for a developer audience.
That's great. I can't wait to read. I'm going to go through what you have there already. Okay, so we have a question. Why should we separate the service and the proxy? Can we integrate the proxy as a library in our applications?
So I think that's referring to this diagram here, right? The answer is you can, and that's kind of what we do in okay. So let's take a classic Spring Cloud example. So we use something like Eureka, right? And we do service discovery with that, and we just make HTTP calls with declarative client, whatever it is. That's fine. You can do it, and you can just absolutely do mutual TLS on your own. It's just more work for the developer. Do you want to, what we're trying to do with the service mesh proxy is we're trying to extract that as a polyglot approach where all programming languages just go over localhost. There's the downsides to that of complexity and performance. But it is what it is, it's a trade-off.
Yep. Everything is, it depends.
Yeah.
Cool. We'll see if we have any more questions come in. If not, we'll give some people a few minutes back today. This has been fun. How long? So you've been working on this kind of subject for 2.5 years. You said at the beginning of this. How much more time do you have to finish that book, do you think? Without putting you on the spot.
I'm hoping just a few months. It's just at this point it's just a matter of writing, because there's sample applications that go with all of this stuff to actually validate these approaches work.
Nice.
And I've actually helped quite a lot of customers over the years kind of implement variations of these patterns in their environments. But they did most of the coding. I didn't. So
Yep. Cool. Well, I'm excited. Like I said, I'm going to go through the chapters that are there. I have the PDF, but I didn't look. How much content is in that book that you're giving away right now?
Well, so the book has like the structure of the book is the first part. The first 2 chapters kind of talk about what you should know about security as an application developer. So it's clearly like, what should you know? What should you not know or not care about, right? And then the next part is the fundamentals. And the fundamentals is really teaching you the stuff that you need to know, but you don't know that you need to know it, right? Because I've observed over the years that if I know that I don't know something, at least I have the opportunity to learn it if I ever needed it. But where I really get stuck is if I don't know something, but I didn't even know that I didn't even know it. Right?
Exactly. And especially, No, go ahead. Sorry.
Yeah, so my goal is like I want to make TLS accessible to developers. In order for TLS to be accessible, unfortunately, you have to know a bunch of cryptography, right? You have to know like concepts like one-way hash function, cipher suite, and public key and a private key and a this and a that. And so what I do in the book is I explain those, but I'm like, my attitude is like, as a developer, I'm building the house. I don't need to know how to make a lock for a door. I can go to Home Depot and buy that lock, right? I just need to know, do I want to buy a lock with a traditional key, or do I want to buy a lock with like a keypad or one that I can control from my phone? And I get to decide where to put the locks on my house, but I don't need to know how the lock, I treat it as a black box. So
because if you don't and you go down that rabbit hole, that you're, like you said, you're just going to get lost. Like there's too many rabbit holes to go down.
You become a lock engineer,
you
become a cryptographer. I don't care about that. I don't want to do that, right? And so there's a consistent sample scenario that I use in the book, which is like, you work for this like online shopping company that sells shoes, and then people buy shoes online, but then they don't like them, so they return them. And like, you work in the warehouse, or you have some application running in the warehouse where the warehouse employees check that the returned shoes are still in good condition, and then they authorize a refund. And then the warehouse management application needs to get a JSON file over to the order management application, so the order management application can refund credit cards. And we go through like, how can you make sure that the file is not corrupted on the transfer? Okay, well, we solved that problem. Now we go like, how can we make sure that it wasn't tampered with intentionally? Then we go through like, how can we make it so that the contents of the file are private? Like,
your microphone went out. I can't hear you now.
Yeah.
There we go.
If I touch the top of it, it goes on mute.
Nifty.
I love about it. I love about this mic. And then the last version of that is like, you don't want a shared password, because it's like, if I encrypt a file and send it to you, and then I have to tell you the password, like distributing the passwords is hard. That's where public key cryptography comes in. So again, it's just and throughout it, like we learn, I show people how to use like how to parse JSON web tokens and all this type of stuff. So you get familiar with the libraries, There's a Spring application for everything. Everything is using Spring Boot. So there's little Spring apps that you can run to figure out how all this stuff works.
Awesome.
And
Cool.
I'm desperately behind on the writing, but I'll speed up.
All right. We have another question here. Let me see if we can bring this in. Can you please tell us how certificates will be validated among service A and service B through the proxy?
Okay.
I'm guessing it's referring to the screenshot.
Yeah. I will share my screen again and bring the diagram back up so we can talk about it. Slides, share screen. Okay.
All right, let me add that.
All right, we'll go here. Okay, so the question is, how is this service A validating the? So the answer is very simple, actually. The way that you validate certificates is the following. Let's take a look at this certificate here. So if I click here, you can see the lock icon. We can see sites. Where is it? Secure connection. Where's the view certificate?
Certificate is valid. Yeah.
Okay, so we click on this. And so when you look at a certificate, certificates have a well-known structure. And you can see that this particular certificate is issued by DigiCert, right? And my browser trusts certificates that have been issued by DigiCert because that's actually hard-coded into the browser, into Chrome. All right? And so what will happen is that it will say, okay, I'm going to calculate digital signature over this certificate. And if I see that the certificate hasn't been tampered with and the certificate has been signed by a certificate authority that I trust, I'm now going to look at the common name in the certificate. You can see here it says star.vmware.com, so any domain from vmware.com. And then, tanzu.vmware.com fits within that, so it'll work. So in the case of Istio, or these proxies here, what you'll notice is that there's a certificate authority that's built into Istio itself, which will create certificates for each of those proxies. And so these proxies implicitly trust any certificates that have been created by IstioD, and they will validate those certificates according to the standard rules of how to validate X509 certificates. Does this answer the question?
Yeah, it sounds like it. That made sense to me. So we'll see if anybody else has any other questions, but I think that sounded good. All right. Cool. So I think I have a couple things to talk about after this, but I think we'll kind of end the presentation there. If people have more questions, what should they do? Is there a way that we can get in touch with you, or should we just start reading your book and that's where we're going to get all the answers from?
I think that you can definitely follow me. Just reach me on Twitter.
All right.
That's a good one. I'll go back to the first slide, which had my Twitter handle on it, at Saikali. Generally, you can always find me at Saikali practically anywhere.
All right.
And then there's the Git, like Saikali on GitHub /Saikali. I have all sorts of Git repos there that have various samples related to this. And if you run into any issues with Git repos, just open up a GitHub issue and tell me what I did wrong there. What's
awesome.
Okay.
Awesome. Well, Adib, we appreciate your expertise in this field, and we appreciate your time today. Thank you very much for coming on and presenting with us.
Thank you very much for having me.
All right. I just want to kind of mention real quick, Spring Academy. This is a really great resource. It's an on-demand education developed and curated by the world's foremost experts in Spring. There's a bunch of really great courses on there. I've actually gone through and reviewed some of them myself. Really impressed with kind of the hands-on learning approach. There's hands-on labs, so as you're learning something, you can go through and practice what you've learned. So if you want to, you can go ahead and sign up for free. You can register for an account for free right now at Spring Academy. I also want to let you know that we hope to see you at VMware Explore. There is a Spring One track, a whole day dedicated to Spring at VMware Explore. That'll be on the first day, and then there'll be topics on Spring throughout. So we hope to see you at VMware Explore August 21st through the 24th. We still have early bird registration prices for that, so please go ahead and register for that, and I hope to see you there. With that, we will go ahead and conclude today's presentation, and we thank you for joining us.